All right, let's begin. All right, so I don't have my textbook. Just a second. I know I'm a frustrated television actor. I think I should have had my own talk show at night. What do you think? You know, bring guests in, and make fun of them. All right. So what are we doing? What's the first thing we're doing?
The falling apple.
The falling apple. Do you think there really was an apple? Can you look that up? Where did the apple story come from? I want to know. Okay, I have all of these high-powered 18-year-olds, international from around the world. Give me where you're from. Where are you from? Where?
You mean where I was born?
Where were you born?
Tunisia.
Tunisia. We have Tunisia,
Texas.
Texas, a country unto itself. Florida. What part of Florida? It depends on where you come from. Like Southeast Florida, they call New Jersey. Okay, yeah, Pensacola is that's actually Florida. Samia, where are you from?
Egypt.
Egypt. She does not look like she's from Egypt, if that has a look, I guess. I don't know. Brianna, where are you from?
Arizona.
Arizona. Excellent. Excellent. Very conservative governor, I think. You know anything about the governor?
No, I know about the lady that got shot at Fry's, though.
Okay. The one that was in the Congress?
Yes.
Yes, that was a terrible thing.
That was. It was like a Fry's I knew and I would go to regularly.
So you went to that place where she was
Yeah.
terrible. Terrible.
It was
Yuck.
so sad. Our school was like.
You were in school. What grade were you in?
I don't know what grade it was. Maybe a freshman.
Ninth grade, whatever it was. You were somewhere.
Earlier.
Somewhere. But you remember the day, and that was your town. What town was that?
Tucson.
Tucson, Arizona. Terrible. Yes, where are you from? Where? Venezuela. I knew that, but I just want to, Yeah. And you are from the UAE. Are you from the UAE? Excellent. Brazil. He's from the great state, the great country. What state in Brazil are you from?
Rio?
Rio. You're from the capital. No, that's not the capital. That's the...
It was the capital.
It was the capital, and many people feel that it's the capital, and many people feel that it's the most important city, although it's not. It depends on your point of view, I suppose. In terms of tourism, I would say it's the most important. The capital of tourism. Would you say that? Can we agree on something? Excellent. And what's the capital?
Brasilia.
Brasilia.
I live
Excellent.
there.
You live there? You used to live there. Excellent. And Professor Oval, where are you from? Where are you from? You're from England. Where are you from in England? I don't think I've ever heard you speak. Do you have an English accent? Okay, I was a little scary because I don't think I ever picked up on that. And why don't you have an English accent there, Melissa? Why don't you have an English accent? You haven't lived there long, or you're embarrassed to sound British, or what? Your dad's what?
My dad sounds British.
Your dad sounds British, but you've lived overseas too much? Oh, I see. When was the last time you lived home for more than a year?
A while.
A while. Okay, I'll take a while. Yes. Where are you from? California. Excellent. Excellent state. 6th largest economy in the world. Yes. I know, and you're having problems too. I know exactly. God, I don't know how you guys do it. Yes. The Philippines. Excellent. Now we have some conversations going on back here. I don't mean to interrupt. Where are you from? Where? Where? UAE. Excellent. Excellent. Are you Canada?
No.
No?
Yes.
I know that have dual citizenship, right? Palestinian?
Yeah, I'm originally Palestinian.
You're originally Palestinian.
Born in North Carolina.
You were born in North Carolina,
Yes.
but you consider yourself Palestinian.
Yeah, both.
Both U.S. and Palestinian?
Yes.
Excellent. Yes, where are you from?
Pennsylvania.
Pennsylvania. Excellent. Mr. Confederate? He was born in Korea, and he considers himself from the southern United States. What state? Alabama. Excellent. Wow, that's serious southern United States. Mr. Germany, right? You're from Germany, right? Originally.
German, Australia.
No, yes, thank you. But where were you born? Australia. Well, you consider yourself both, which is good. And how long have you lived in Germany, where you feel yourself more heritage German? You just 1.5 years? Excellent. He has a very heavy Australian accent, but I'm deaf and it's hard to tell. Reem, you are UAE. Yes? And the bear, you are UAE. So that's a UAE lab partners back there. Excellent. Now, just wanted to do that. That was kind of, we're stalling. So, did anybody look up the Apple story? Did we find that, or yes, we have we have an answer. Yes.
You did actually pull it.
Mr. Tunisia, what'd you say? Could we have attention, Reem? Reem, yes, thank you very much. I appreciate that. The bear is difficult to be with. He's very friendly. Excellent. I will try not to call him the friendly dancing bear, but anyway, carry on.
So he was sitting in the garden.
He was sitting in a garden,
And an apple just fell.
and the apple just fell in the garden. He was sitting in the garden. A garden is like his yard, his backyard. Like backyard, they call English. They call the yards. In the United States, we call them. In England. In the United States, we call them the yard. But in Britain, they call them the garden, right? So in the garden, in backyard, and an apple. He just saw an apple fall, or it fell on him.
No, he just saw it. And
He just saw it fall,
he just asked himself why.
and he pondered why.
Yes.
Now, did this predate his theory of gravity or postdate his theory of gravity? Like, when did it happen? Do you have a year on that? Samia? You look like you're hard at work here.
Yeah, she's like,
All right, why don't you get back to me on that? Let's be, yes, carry on.
Does it take like 1752?
1752.
When it says it was published.
That's when it says what was published? The gravity?
No,
The story was published in 1752? I feel like I'm a dentist pulling teeth here.
Didn't it like stay dormant for 20 years though?
That's
Kinda
what
like
it
that
says.
light.
I,
Back to it.
no,
Brianne, people are talking. I can't make out your voice. What did you say?
Never mind.
No. Oh no. What did you say? I want to know.
Didn't he like leave a series of gravitational pulls and like left it for 20 years to go on to work on other facets of physics like light, and then finally came back to it?
So what you're saying is he started his developing the theory of gravity, left it, and came back.
Yeah, with like
Okay.
more supporters.
I like that. Is that true? Is that true? Are we looking? Let's look up Newton and start reading up on him a little bit. Okay. All right. Yes, Samia.
it said that he saw the apple fall, and then it took him over 2 decades more to develop the full, like,
He saw the apple fall, and then it took him 2 decades more to develop the theories of gravity.
yeah, the universal gravitation, like, yeah.
So he saw the apple fall,
Yeah.
and then 2 decades later, he finally published something. Okay, let me do something on film, and I don't mean to embarrass anybody, and I will not do names, and I'm sorry the world has to see this because the world looks at this stuff. I have hits from all over the world. Could I have everyone's attention, do you think? Unless you're looking up something, I ask you to look something up. Because you see, we're going to be doing the Apple, which is this group, right? But everybody's got to be here. Your group is Apple?
Yes.
Well, I thought we were doing section 1.
Yes.
Are you 1? Oh, you're 1. Who were you? Oh, because you were sitting elsewhere. Okay, you might want to sit with your partner. That's why I was a little confused there. But thank you very much. So you guys are 1. Have you said anything yet with the Apple? Sophia and Mark are the Apple people. So everybody's got to stay on this because I want people, start looking up stuff. We're on section 1, right? So while we're talking to this, you want to A, be listening, but B, looking up stuff on section 1 so that you can feed me. We're not just one group isn't doing it. It's not me and these 2 people. It's me and everyone, okay? Yes, carry on.
Okay, so
Bullets, come on, let's go, let's hustle.
do you know what gravity is? Do you want to put that out there?
Do I know what gravity is?
Do you want that?
Yes, what's gravity?
It's a force which tries to pull 2 objects towards each other.
It's a force that tries to pull 2 objects toward each other. And what is that force based on? She's reading right from the book, which is a little bit annoying. Not annoying in terms of mad, but what I want you to do, Sophia, I don't mean it's annoying, I guess. It's a little frustrating. I want you to put it in your own terms. If you sound like a textbook, I mean no disrespect, but you sound like a textbook. Nobody talks that way. Yeah, so what do you think gravity is? Put it in your own words.
So it's just like two objects acting upon each other.
It's two objects acting upon each other. And what do you think it's based on? Do you have any guesses? What's it based on? Yes.
Mass and distance.
Just the mass and the distance, and that's really all it is. The fact that the two objects are the objects and how far apart they are. That's it. Now that's Newton's theory. We have other theories which we'll talk about in our next class relative to going to the planetarium, but this is it. This is gravity. You ready? This is it. This is it. You ready? All mass has a natural tendency to attract another mass. That's it. These two masses have an attraction. It's not electrostatic. It's not based on positive and negative. It's just based on the fact that all mass, all discrete mass, all mass, separate mass that I can see. One, this is one. Do you understand that this is one phase? What's a phase? In other words, one set of physical boundaries, right? This is one set of physical boundaries. I know that that's a marker. I see that. Do you see that that's a marker? You see the boundaries of that? Those boundaries, that will attract this one. They will attract this piece of paper. No, it's pulling. I can't. No, it's not magnetic. It's just the fact that all masses have this tendency to attract each other, and that's really it. That's there's nothing else. There's nothing else. Do you see that attraction ever during the day between two small objects? Thank God no one raised their hand. No, you don't see it. Where do you see it? What do you see it? Where do you see it?
Something falls to the ground.
Yeah, you see it. You see it between which two objects? Give me two examples.
Ground and ball.
All right, the ground and a ball. Let's be more specific. Well, I guess the ground is pretty specific. The earth and the ball. Right? You sound like you're from the Middle Ages. The ground and the ball. I don't know where ground ends, but ground and ball. I don't know. Okay? The earth is flat. Okay? No, you have the ground, the earth, and a ball. All right? Is there anything else in that section? It's just kind of just there to wet your whistle, isn't it? Do you see anything else there that's worth talking about? Yes.
Inertia.
Inertia. Well, what is inertia? We've talked about inertia. Inertia is from physics. When you had physics, many of you have had physics. Yes.
When an object is in movement and wants to obey movement.
Okay, that's the classic definition. Absolutely. Inertia is a tendency. I think that's what a lot of physics books will say. Inertia. Newton's first law. Yes? If an object is in motion, it tends to remain in motion. If an object is at rest, it will stay at rest. Correct? Unless acted upon by an external force. If you're in a car driving down 10E and you take your foot off the gas, you don't touch the brakes, what will eventually happen?
Slow down.
You'll slow down and stop. Is that in violation of Newton's first law? Is it? Is it in violation of Newton's first law of inertia? Why or why not? Anybody? Yes.
I think it is.
It is in violation of Newton's first law of inertia.
Because isn't inertia that it says that the object has to keep moving in a straight line?
Okay, it's going to keep moving in a straight line. All right, let me restate. I don't know if this is in the book, but this is like a Darcy definition. When you start to sound like a book, it means you've been teaching too long and you should retire. I did retire, but I have to go a second time in a few years. But I'm starting to sound like a textbook. I know, it's really scary. Let me tell you what inertia is again. You ready? Inertia is a tendency of an object. What's an object? Some kind of mass as opposed to energy, right? It's a tendency of an object to remain in motion or at rest, if it's at rest, unless acted upon by an external force. In other words, it's not internal to that object. It's external. Let me say it a third time. Inertia is the tendency of an object to remain at rest or in motion unless acted upon by an outside force. In other words, if I have this on a table, that's going to remain at rest unless I have an outside external force acting on it, correct? A car on 10E is going to remain in motion unless acted upon by an external force. Now, Samia, God bless all Egyptians, but Samia said that that's in violation. The car on 10E that's gliding to a stop, you can picture it, you can almost feel it, can't you? You can identify with it. You're there, aren't you? You've embraced this whole concept, haven't you? You can feel your car gliding to a stop. You've probably done it before, somewhere in your former life or this one, somewhere. You've had an experience where you've just simply glided to a stop without applying a brake. Is that, let me ask you again, is that in violation of Newton's first law of inertia?
No.
No, why?
Because us pushing the gas pedal is like...
It's an external force.
Yeah.
What's the external force that stops the car on 10E called? It's the F word. No, not that word. It's called what? It's called friction. Yeah, friction is an opposing force that actually stops the car. You thought I was going to say something else perhaps. No, it's friction. So that's true. Now, the marker that was in my hand, what was the external force that made that fly? My hand, I applied a force. Yes? Let me tell you something about physics. This is Newton's second law.
How many laws do we have?
There's 3 laws. This is the first law. This is the second law. In other words, if I apply a force to a mass, it will accelerate. And it will keep accelerating until you get 10 times past light speed, warp 13. No, just kidding. It can't actually hit the speed of light, but that's modern physics. But what I'm saying to you is, the object will continue to accelerate as long as a force is being applied. Yes? If something is flying to the moon and there's no force, how does it continue to move to the moon? Well, there's no external force. There's no air molecules in outer space. There's nothing to stop it. There's no external force if the rocket is on its way to the moon, is there? If something's flying in space, you've seen many movies like Avatar, where these giant spacecraft can go through space. You've seen, anybody ever see a great movie, Hitchhiker's Guide to the Galaxy, something like that?
Yeah.
Great movie. A little silly, but very good. I liked it. Where it doesn't matter the shape of the vessel, does it? Because there's no air. It doesn't have to be, what? There's no aerodynamics involved, is there, in space? It could be like a giant cube, couldn't it? Like the Borg. Yes? Resistance is futile. Okay? Do you understand? So when you're talking about Newton's first law, you have to have an external force if it's going to stop moving or begin to move. Newton's second law says that something will continue to accelerate as long as I apply a force. Think of pushing a cart down an aisle in the grocery store. You're not pushing very hard, are you, to go down the aisle? Aren't you going at a constant speed? The constant speed is you walking, right? But why aren't you applying a large force? Because it has wheels, okay, but you're applying only a small force because it has wheels, but what relative to Newton's laws? And this is really the hardest thing for a young physics student to wrap their head around. This is one of the hardest concepts in all of mechanics, what I'm trying to get you to understand right now. And it has to do something as simple as going shopping with a cart. And that example is one of the most difficult aspects of all of physics, the beginning of physics, called mechanics. Why is it easy if something has wheels? Why do you only have to apply a small force to that cart to keep it going at a constant speed? The constant speed is you're walking. Don't you walk at constant speed? Wouldn't it be horrible if you're constantly increasing speed? You'd be exhausted by the time you got home, wouldn't you? Yes, Alan.
Because since it has wheels, the force of friction is less.
Okay, it has wheels. The force of friction is less depending upon how the wheels are. Is it wooden wheels with a wooden axle? No, there are ball bearings and all kinds of things that reduce the structure of the wheel. The modern wheel reduces friction because of its construction relative to ball bearings, etc. Anybody else? Yes.
Force required is distributed to the four wheels.
Excuse me? The force is distributed on the four wheels. I like that. So each wheel is carrying, depending upon the design of the cart, it's equally distributed on all four wheels, maybe. Maybe the design of the cart, maybe, I don't know. It depends on the design of the cart, but that's possible. What else? Anybody else? Why? Well, I'm going to give you the reason, because we were going to be ending soon. But the reason is Newton's first law, that cart is moving on its own because of Newton's first law. That cart will continue to move unless what? Unless a what? Unless an outside force. So the force that you apply to get the cart going is really all you need. Now, you're not applying any force to that cart to keep it going. What force are you applying? The force that overcomes what?
Friction.
That's it. You're only doing the friction. So that you're not applying a force to keep the cart going, because the cart's going on its own. Do you understand that? The cart is moving completely on its own. All that you're applying, and are you applying more than the frictional force? Are you applying more than the frictional force to that cart? Going down aisle 1, dairy. Are you applying more than the frictional force, less than the frictional force, or equal to the frictional force? Can everybody start participating? This is getting a little dull. What is it? Why do you say it's equal to the frictional force? Well, how do you know? I mean, I'm going to ask you a question. Based on what we've discussed, what obvious observation can you make that will tell you that the force that you're applying is simply equal to the friction? What observation can you very easily make? That's what you're applying. So these are equal, right? That's the friction. This is the friction. They're balancing out, right? This is not force, this is velocity. I'm going in that direction. Okay, that's velocity of the cart. Okay, it's a vector, I can say that. Okay, so why are these forces, why must they be equal? Because acceleration equals 0. You're not accelerating, are you? Are you accelerating? What's the only way you can accelerate? Is if you have a net force. If you have a force that you're applying a net force. This has no force. That was applied to get it going. I accelerated to a certain velocity, right? Yes? Then I can stop applying that force. Yes? Now the force is just equal and opposite to the friction. So, do you have to apply a force to the cart to make it go at that velocity? No. The force that you're applying is not for the car to go at a constant velocity. The force that you're applying is simply to overcome friction, because the cart's moving on its own because of Newton's first law. Isn't that cart heavy? How many people have ever pushed a heavy cart, man, full of groceries? And it's hard to get it going, isn't it? But once it's going, it's easy, right? So that force that you applied to get it going, that's the serious force, isn't it? Right? But once it's going, do you have to apply that same force? No. You have to apply a small force. Why? Because you're only applying the frictional force, the opposite. Clear? Are we done section 1, do you think? Is there anything else there, Sophia and Mark? Does anybody else want to contribute anything? Hey. Sundays are tough. This is like Mondays. They write songs about Monday. You want a good song about Monday, just think Sunday. Look up Mamas and Papas, Monday, Monday. Can't trust that day. Have a great week.